All right. Class.
Yes.
Okay, that one's pretty good. That was pretty good. Okay. My last class was kind of weak on that one. They didn't want to participate. They didn't. But you people, you want to participate. You're not playing with your phone right now because you're actually want to get a good grade on this because this is a lot easier than what we did on 5.2. 5.2, I told you 5 is the hardest unit. 5.2 is the hardest unit in the hardest unit. So, from that point on, it's all downhill. This one's going to get a lot easier. So, if you got your reference sheet, if you got your unit circle, now, go find on your reference sheet where it says sum and difference for cosine. Cosine, sum and difference. Cosine, sum and difference. Sum and difference for what? Cosine. Sum and difference for cosine. So, here. Jaquan, here. There you go. Look. See? Sum and difference identities. That's what we're going to be using. No, I know you don't see that because you don't wear your glasses today.
I can't see far. I can see clear. Thank you, Jay. Instead of... Where's it at, though?
It's not there.
Oh, okay. I see it. It doesn't say sum of difference.
One says sum, and the other one says...
Sum and
difference.
You made it seem like something was saying this song.
Yes! That's my Edgar right there. That's the Edgar. Just say no to Edgar. All right, sum and difference identities. Okay, for cosine. So we're only going to be using the ones that have cosine. Now, on the reference sheet, your two variables that are using are s and t. Those are just representing the two different variables or the two different values you're going to be adding together. But in this case, for these notes on the note paper, it uses a and b. So I'm going to explain now that this uses a and b, but on your reference sheet it says s and t. So that's just, the only difference you got to deal with right now. All right, blah blah blah, blah, blah 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 blah. Do you really want to do all this? No. Good. Thank you. All right. Nope. Do it again. Nope. There we go. Hey, these are the identities that we're dealing with. And if I just threw a highlighter at you, highlight these two, because these are the two that we're going to be using.
But you didn't throw a highlighter.
I threw one at Gustavo a moment ago. I'm not going to throw anything at you. Like seriously, you're going to have to like screech at it, like ah, kind of like a bat or something, just to find it, because I don't want to hit you.
You don't want to be on TikTok again?
Again? I don't know what you're talking about. Okay, I'm on TikTok for my salsa videos. Okay.
You mean like dancing or?
No. Yeah, like actual because my salsa's fire. Okay, so I threw one at Gustavo, but okay, I was so skilled it just hit right there on that tray. Yeah, that's it.
Oh,
that's amazing.
Okay. Whoa, it's amazing. Oh, Jay, I love you, man. I do. Like some of the things you say, you make my day. You really do. All right. Anyway, these are the two that we're going to be using right now. Now, find the exact value. That's what we're doing. Exact value of cosine 15. But wait, 15 is not on my unit circle. It's not, is it? Whoa. It's not on the unit circle, but we're going to find the exact value. So that means do not plug it in the calculator because that is not an exact value. Now, we're going to use sum and difference. So mathematically, the term sum means I'm going to add. Difference means I'm going to subtract. So we're going to either add or subtract here to get 15. Now, the only numbers you're allowed to use are the ones on your unit circle. And if this is 15 degrees, now let's go ahead and look at my unit circle. Looking at all the degrees on my unit circle, right? Using either addition or subtraction, how would I get 15? Subtract what?
Oh, wait.
45 minus 30. What are you trying to get?
15.
And how are we going to get 15?
I don't get that, because can't you just subtract the 15 from the 30?
Yeah, or you can even add.
Is 15 on your circle?
No.
Thank you. So you can't just do that. You only could use what you have on your circle. And what do we have on the circle?
Oh.
45.
Minus 30.
45 minus 30. Is that going to give me 15?
Yeah.
Yes, it is. So that's what I'm going to use on this one. Does that make sense now? So now, using that formula we just had, so it's cosine of 45 minus 30. Because 45 minus 30 is 15. That's where I'm getting that from, okay? And that's the value 15 that we're trying to get at. But now we're going to plug this in. We're going to plug this into that formula that was on the previous page. So this is going to be equal to, so in this instance, this is my A, and this is my B, from these over here. Okay? And it's on your reference sheet also, and your notes. So this is going to say cosine of 45 times cosine of 30 plus sine of 45 sine of 30. I just plugged it straight into the A and B values from my formula. Now again, I'm going to use the unit circle here because I'm going to need some values from this. So on my unit circle, the values, so cosine is the x value. So cosine at 45 is going to give me what? Rad 2 over 2. Cosine at 30 is?
Rad 3 over 2.
Very good, rad 3 over 2. Plus sine 45. Very good, rad 2 over 2. And sine 30. 1/2, right? Do y'all understand where this come from? This is all, I'm picking these values off the unit circle. Now, we're going to multiply these together. So when I multiply fractions, I multiply top times top, bottom times bottom. And when I'm multiplying radicals, I can multiply what's inside together. So this is going to be rad 2 times rad 3. I multiply inside, so it's going to be rad 6 over 2 times 2 plus rad 2 times 1 over. Now, do they have common denominators? Yes, so can I write them together over a common denominator? Yes. So that's going to give me rad 6 plus rad 2 over 4. And I circle that.
Please tell me that's our final answer.
Wait, so you
And we
can
have to
just,
do more.
you can't just add the six.
So I should be like, wait,
You get eight.
What?
You can't add the
No. They're different. So when you have radicals like this, you cannot add them together unless they're the same. You treat them as if it is a variable. You treat them as if it is a variable.
and that's all.
Yeah, and that's it. So it's almost like all these people all up on their phone right now while I'm trying to give you instruction.
Yeah.
You do not, yeah.
Yeah.
Are we okay with that?
Yeah.
Okay, good. Let's see if you paid attention.
No.
Yeah, I know that. Yeah, that didn't happen, right?
No, I did actually.
Now,
Oh.
so what's wrong about this one?
It's pi on it. And it's a fraction.
But what is that though?
in radians.
Say it, Jay.
It's in radians.
It's in radians. So what do you think I should do to try to actually make this easier? Convert it to? Very good. Convert it to degrees. So I'm going to convert it to degrees. Now, what am I going to multiply by to convert this to degrees? 180 over pi. Very good. Go ahead and multiply that out. Yeah, you gotta use your calculator, not your TikTok.
Wait, is this the one where we do it for the pi or do it?
You can if you want to, but what's gonna happen here?
Are we supposed to change the calculator?
Oh, isn't it? Don't we use one instead
Won't, hold on. Yeah, won't the pi's cancel?
Yeah. So the
And if the pi's cancel, what's on the bottom down here? Over 1. Okay, so yes. On this one, it is going to cancel, so you can get your answer, which is going to be
wait, 1 second.
75.
75. Very good.
75 pi.
Not pi, because what happened to the pi's?
Oh, it left.
It left. It canceled, right? They were gone. Now we're going to do the same thing, but this one is 75.
You can do 60 and
What numbers am I going to use to get 75?
40 and 45 and 30. Add 'em.
45 and 30, right? So we're going to add 45 and 30 now. Yes.
Does it matter if you use the subtraction or addition?
It doesn't matter. It's going to give you the same answer. It's going to give you the same answer. So you don't even have to use 45 and 30. What do you use?
135 and 60.
Yep, 135 and 60. Okay? So 135 minus 60 will give you your 75. It will still give you the same answer. So you could use multiple different things, but you still end up with the same answer. Excuse me. So, in this case, I'm going to use addition on this one, and I'm going to have you people finish off this problem. So it's cosine, we said 30 plus 45. There we go. Now, your job right now is use the notes, fill it in of what you're going to write on the right-hand side with your A and your B.
Does it matter about big numbers going in kind of like, does it
No.
matter what order?
No, it doesn't matter.
wait, so we subtracted.
All right, let's see what we got. Well, I'm going to start working it out. Can't wait forever for you. Cosine 30 cosine 45 minus sine of 30 sine of 45. So this is going to give me cosine at 30 is going to be rad 3 over 2. Cosine at 45 is rad 2 over 2 minus sine of 30, which is going to be 1/2, times sine of 45 is going to be rad 2 over 2. And when I multiply them together, I get rad 6 over 4 minus rad 2 over 4. And as I put them together, I get rad 6 minus rad 2 all over 4. Is that what you guys came up with?
That's what I'm getting to.
What? You didn't? Where'd you stop at?
Oh.
Did you
Wait,
plug
but
in?
I thought you said you can't.
Can't
add
what?
those.
I didn't add them.
The 3 and
It's still-
2, but you gotta.
No,
you
that's a
said you
multiplication.
multiply those.
Yeah, multiply these. I can multiply the insides. I just cannot subtract them, so that's why it stays as rad 6 minus rad 2.
Wait, so to get from radian to degree, it's 180 over pi
Very good.
to get to degree. I mean, will we ever need to get to degree to radian with this?
No, because is it easier getting 75 using degrees, right? It's a lot easier using degrees, isn't it? So you're probably not going to need to go back the other way to radian for any reason. All right, are we okay here? Alrighty. So what I'm going to start off with is I'm going to do the next one, and then I'm going to pause, give you about 10 minutes, and then do the next, then number 2. Okay? So let's do that.
I was gonna ask her if it was not that I'm complaining.
The what?
Why I decided not to say it. Like, what are you gonna give us 10 minutes for?
What do you think I'm going to give you 10 minutes for?
Well, 10 minutes isn't enough time.
I know, but it's enough to do a couple of practice, right? To make sure it like stays up here before you like fell asleep on your desk and it just like drips out your ear.
Okay.
Yeah, because that happens often. Okay, all right, right here. So now this one is backwards. This one, if you notice, it goes cosine 87, cosine 93, minus sine 87, sine 93. Now, I'm going to go to my formula. So this time, we have the right side of the equation, right? We have the right side of the equation. So what is the left side of the equation going to look like? Cosine A plus B? Yes? Or is it A minus B?
Oh wait, minus. Wait, no.
Plus.
Okay, because we have a minus sign in ours, right? In ours, we have a minus sign, so if I'm going to work to the left, that means it's cosine of A plus B. So that means this is what I'm looking for. So it's cosine of A plus B. And in this case, my A value is 87, very good, plus 93. So yes, I'm working it from the right side to the left. Almost. Almost. What is 87 plus 93?
100 and
Yeah. So cosine 180. Is 180 on my unit circle? Yes. So cosine at 180 is going to give me -1.
So we have to stop right there when we get a number?
Then we're done.
wait,
So
that's-
cosine 180. Cosine 180, like I am almost 100% all the problems that are like this are going to give me some number here that is on my unit circle.
And if that's the case, we have to.
Then you give me whatever that is. So then you go to the unit circle under 180, and cosine is the x value, right? So the x value at 180 is -1.
What about the other side?
We don't need the other side because I use the right side. I use the right side to figure out the left side because on the previous problem, I made the left side and I used the right side over here, right? Does that make sense or no?
So like the cosine and then the sine. Like you only did the cosine.
Wait, those problems were like together?
No, yeah, no. Look, right here. See all this?
Yeah, I know.
This is all the right side of my formula, isn't it? Say yes. Don't say sure.
Because they're the same number.
See this right here? This is the right side of the equation, isn't it?
Yeah.
And the one that I have, this one was 87 and 93. This one was 87 and 93.
Yeah, but you already did the cos.
No, I did. I did it both.
No, you.
I did it both because all of this together turns into the cosine A plus B.
So
Be-
we don't have to
now-
combine.
No, because sine, look at the reference sheet, I'll show you. Sine is a different formula. Okay, sine is a different formula. Sine goes sine, cosine plus cosine sine. Where the cosine goes, cosine, cosine minus sine, sine. That's what we're doing. That's what we're comparing. Does that make sense now?
Yeah.
That's why it comes back to being a cosine problem. Yeah.
Oh, because this equals that.
Yes, that's where we went.
Oh, okay.
Yes.
Yeah, I get it.
Okay, good. All right, so that's it. So I'm going to pause right here, and we're going to start 5 through 12. I'm going to give you about 10 minutes, and y'all going to do some work. All right, let's get back to this, my class. Oh, man. Okay, that was kind of weak right there. That was super weak. You know what? I was super disappointed in that one.
Let's do it again.
I know. Okay, let's try this again. Since we are continuing here, let's try this. All right, class. Yes. Woo. Okay, that one's better. Good job. All right. So hopefully you're stopping where you're at, and we're picking up right here. So co-function identities. We've done these before. We've done them before. We've done them a lot. We know that both angles together in a triangle have to add up to, say, 90. 90, because it is a right triangle. You said 180 because a triangle adds up to 180. But this right here is 90, but the other two, which I'm going to call my alpha and my beta, those two together will equal 90, right? Because all three together add up to 180. So I know that A plus B equals 90. Okay? So whatever those angles are, they're adding together to be 90. Now, for this next part, but what if it's in radian? If it's in radian, it would be A plus B is equal to pi over 2. Where did we get that from? It's almost like on your unit circle, you find 90 and you look to see what it is also referred to as. And you're going to tell me? Pi over 2.
Pi over 2.
Pi over 2.
Pi over 2.
Pi over 2. Pi over 2.
Wait, where are we getting this?
I don't know. It's almost like the notes that you have going with that right there. But someone wasn't paying attention when I started that. Yes, you can. That would be a good thing, right? Oh, we are so good at fighting. We are so good at fighting. Anyway, all right. We good here now so far?
Oh, yeah.
Okay, good. So if they're radian, they both add up to pi over 2. If they are degrees, they both add up to 90. So co-function identities add up to 90. So cotangent theta plus tangent 25. All right, on this problem right here. This problem right here. Both those angles together have to add up to what? 90. So to figure out whatever the cotangent is over here, I would do what? I would subtract, right? So it was going to look like this. It's going to be cotangent of 90 minus what? 25. Isn't it? Yes. So what is 90 minus 25? 65, isn't it? So cotangent of 65 is equal to tangent of 25. So what I was actually looking for here in this case is this answer over here on this side. So theta was 65, wasn't it?
Yeah.
Is that pretty easy there? Yeah.
Like dun dun?
Like dun dun dun. All right. B, sine, cosine negative 30.
Oh, for this one, it's gonna be like 90 plus 90.
Kinda.
90 minus, no.
Say the whole thing though. I agree with you, but how'd you get there? You're skipping a step.
Well, no, but I'm saying like in the end, like it's gonna be 90 plus 30.
Yes, but I want that step in between. So together they have to add up to 90. So how would I start by saying this? Sine of 90 minus negative 30. That's important. Negative 30. Put the negative with it. Because when I have a minus a negative, that means I have two negatives together. So a negative and a negative gives me a... Thank you. That changes that to a plus now. Because I have a minus and negative. So that's going to be sine of 120 is equal to the cosine of negative 30. Now, is this true? Because negative 30 and 120, when I add those together, will give me 90, right? It'll give me 90. That's what I'm looking for there. ¿Está muy fácil? Muy fácil. Cosecant 3 pi over 4 equals secant. Is it x?
Yeah.
Okay. This one's, there we go. There we go. Now, what's different about this one? It's in radian, right? It's in radian. So instead of adding to 90, these two have to add up to pi over 2, right? Radian, look at your unit circle. Put your finger on 90 degrees. Put your finger on it, take it out your nose and put it on 90. Thank you. What is 90 in radian? There we go. That's where we get pi over 2. Okay. All right, so together, both of these have to add up to pi over 2. So I'm going to go secant of pi over 2 minus three pi over 4. And I'm going to leave this like this because, not like this, but I'm going to leave it in radians because fractions are your friends. Okay, I blame all your middle school and elementary teachers that were afraid of fractions, and because of that, they didn't teach you fractions. They didn't give you a respect that fractions deserve. So, to be able to combine these together, what's got to happen? Common denominator, right? Common denominator. So what's the common denominator in between the 4 and the 2?
4.
It's going to be 4, right? Yeah, common. So I'm going to multiply this by 2 over 2. 2 divided by 2 is 1, isn't it? Yeah. It just looks funny. So I'm not changing the value. I'm changing the way it looks. So as I multiply this, it's going to turn into 2 pi over 4 minus 3 pi over 4, right? Now, can we do that now? We now have common denominator. So I have 2 pi, and I take away 3 pi's.
1 pi.
1 pi.
Negative pi. Because I'm taking away more than what I have, right? Yeah, I have 2 pi's, but Jay goes and eats 3 pi's. Okay? So, yeah, I have 1 negative pi because of that. Does that make sense? Okay, good. All right, so it's going to turn into secant of negative pi over 4. Does that make sense? Hopefully? Okay, good. So, don't forget, like, share, and subscribe. Hit that notification button and buy stuff from my merch store. So, go ahead, and from here, we are going to finish up the homework. And, yeah, like I said, like, share, and subscribe.